Hey guys, this is the week 26 supplementary video. Okay, so week 26 is a new subject or a new chapter. Okay, this is called trigonometry. Okay, trigonometry. So mathematically speaking, trigonometry is a very important math branch that can solve a lot of problems. Okay, so in the current stage, we just need to know that trigonometry deals with triangles. Okay, trigonometry deals with the side lengths and angles. Okay, it deals with the relation between sides and angles in a triangle. Okay, to be more specific, for the current stage, trigonometry deals with right triangles. Okay, so this deals with right triangles. Okay, so let me remind you, what is a right triangle? A right triangle is a triangle that has a 90-degree angle. Okay, so we know each triangle has 3 angles, right? That's why it's called triangle. If one of the angles in a triangle is 90 degrees, then we call this triangle a right triangle or a right angled triangle, right? So a right triangle means it looks like this. Okay, it looks like this. Let's call this A, B, C. If a triangle has a 90-degree angle, this one, then ABC, we call ABC a right triangle. It's always good to organize these like very random knowledge. Okay, it's always good to summarize them, to organize them. Okay, so these are just very basic common sense, right? Very basic knowledge. Okay, so let me ask you this. Okay, so before we studied trigonometry, had we ever dealt with right triangle? Let me repeat my question. Before we studied trigonometry, had we ever dealt with right triangle? Did we like did we learn any theorem or theory that dealt with right triangle? The answer is yes. Okay, the answer is yes. We studied Pythagorean theorem, which deals with right triangle. Okay, so it's always good, it's always a good idea to try to connect all the stuff that you have learned together and see if there's any connection between them. Okay, so your knowledge, so everything you have learned will become a system. Okay, rather than like random points. Okay, it will become a system. So let me remind you what Pythagorean theorem is. So Pythagorean theorem says, if a triangle is a right triangle, let's say if triangle ABC, let's say this one, okay, is a right triangle, then AB square plus BC square is equal to AC square. Okay, AC here is called the hypotenuse of this right triangle, right? We'll see this concept very often in this week, okay, in week 26 materials. Okay, so this is Pythagorean theorem. Okay, so now let's officially start reviewing trigonometry. Okay, trigonometry. So in week 26, we learned that trigonometry deals with right triangle, right? And we learned a few terminologies of a right triangle, right? We learned something called a reference angle. We learned something called adjacent side, and we learned something called the opposite side and the hypotenuse, right? So let's carefully review these concepts. Okay, so what is a reference angle? A reference angle is very easy. Okay, if we are talking about angle C, then angle C is the reference angle. If, on the other hand, if we're talking about angle A, then angle A is the reference angle. So basically, the reference angle refers to the angle in this discussion. Okay, the reference angle refers to the angle in the current discussion. Okay, so that's reference angle. So now, okay, so let's say our reference angle here is angle C. Okay, so let me write it here. Our reference angle is angle C. Okay, we learned two concepts. Okay, one is called the adjacent side, and one is called the opposite side. I don't think I gave you a very precise definition of these two concepts. So let me take this opportunity to give you the very detailed definition of adjacent side of a triangle and the opposite side of an angle. Sorry, not a triangle, adjacent side of an angle and opposite side of an angle. Okay, so let me write it here. Definition. Okay. In a right triangle, the hypotenuse is the longest side. The hypotenuse. The hypotenuse is the longest side. So let's look at the triangle that we drew here, ABC. In the triangle ABC, AC is the hypotenuse because AC is longest. Okay, AC is the hypotenuse. Okay, let's continue. And opposite side is the one across from a given angle. And opposite side is the one across from a given angle. So let's again go back to our example. So in our example, the reference angle is angle C, right? So this is the angle in our discussion. And if our reference angle is angle C, then what is the opposite side of angle C? And opposite side is the one across from a given angle. So this is the reference angle. And this side is the one that across from angle C. And therefore, AB will be the opposite side of angle C. Okay. So AB will be the opposite side of angle C. Okay, let's continue. An adjacent side, is next to a given angle, is next to a given angle. Adjacent side, okay, is next to a given angle. Again, let's come back to our example here. ABC, angle C is a reference angle. Okay, then which side is the adjacent side of angle C? Obviously, it's BC because the side BC is next to the angle C. Okay, so BC is the adjacent side of our reference angle, angle C. Here, we have to understand something, okay? In a right triangle, hypotenuse is fixed. There is only one longest side in a right triangle, but opposite side and adjacent side depend on which angle is the reference angle, okay? So for example, we're talking about angle C here. So because the reference angle is angle C, the one that's across from it is AB. So for angle C, AB is the opposite side. Because the reference angle is angle C, BC is the side that's next to it. So BC is the adjacent side of angle C. But if we change our reference angle to angle A, if the reference angle is angle A, then BC will be the side that's across from it. So for angle A, the opposite side will be BC. If the reference angle is angle A, then AB will be the side that's next to it. So AB will be the adjacent side of angle A. So the point here is opposite side and adjacent side depend on the reference angle. Okay. Okay. Let's move on to the next topic. So now that we know, what hypotenuse, adjacent side, and opposite side mean, now we can start learning sine, cosine, and tangent. Okay, it's actually very easy. Sine theta. Okay, let me draw a graph here. Yeah, that's good enough. So A, B, C. And again, let's use C as the reference angle. Okay, so let's call this angle theta. Okay, remember I gave you a very, very, very useful way of remembering this. Okay, let me write it here. Hopefully you still remember it. Okay, just give me 1 second. I give you a very useful trick. Okay, very useful trick. It's called so ka twa. Okay, so ka twa. What does this mean? What does this mean? It means for sine theta, sine theta, S refers to sine, right? And O refers to opposite side. and H refers to hypotenuse. This means sine theta is equal to O over H. So sine theta is equal to the opposite side of theta over the hypotenuse. Okay, so let me give you some numbers here, so it'll be easier for us to understand this whole thing. For example, AB is equal to 3, BC is equal to 4, and by Pythagorean theorem, we can find that AC is equal to square root of 3 square plus 4 square, which is 9 plus 16, which is 25. So AC is equal to 5. Okay. So sine theta is equal to the opposite side of theta, which is AB, because this is theta, right? And the opposite side of theta should be the one across from it. So AB will be the opposite side of theta, which is equal to 3, right? And hypotenuse is 5. This means sine theta is equal to 3 over 5. Okay, so this is sine theta. Cos theta. Cos theta, by this little trick here, we know C stands for cos, right? Cosine. And A refers to adjacent side, adjacent. H refers to hypotenuse. So cos theta is equal to the adjacent side of theta over hypotenuse. Adjacent side of theta over hypotenuse. Okay, let's come back to our graph here. Cos theta is equal to adjacent side of theta. Adjacent side is the side that's next to it, which in this case is 4, because BC is the side that's next to our reference angle. So this is equal to 4, and hypotenuse is 5. So this means cosine theta is equal to 4 over 5. Okay. Last one is called tangent. Tangent. Tangent theta is equal to 3, which is opposite side over adjacent side. So let me write it here. Tangent theta is equal to the opposite side of theta over adjacent side of theta. In our example, the answer will be opposite side will be 3, adjacent side will be 4. So the answer will be 3 over 4. Okay, so this is sine, cosine, and tangent. Okay, there is a lot more to this. Okay, this is a very basic stuff about sine, cosine, and tangent. But for now, this is enough for us. Okay, we just need to know that sine, cosine, and tangent, these three, I want to say functions, I would say these 3 things are basically just 3 ratios. Okay, 3 ratios. Sine theta is the ratio of the opposite side of theta and hypotenuse. Cos theta is the ratio of adjacent side of theta and hypotenuse. And tangent theta is the ratio of opposite side of theta and adjacent side of theta. Okay, so this is sine, cosine, and tangent. And you have to remember this trick, so, ka, twa. Okay, so let me check if there's anything else I want to talk about. Okay, I guess that's so that's everything I want to talk about for now. But we didn't finish our class note in week 26 class. So by this minute, I have been doing a review on what we learned in week 26. So everything here basically covers everything we learned in week 26. But now I'm going to finish the week 26 class note, okay, because we still had a page left. We didn't have time to talk about that page. Okay, so let's get started. So number 3, finding an unknown side. I actually don't remember what this is about. So let's do this together. Whenever one angle and one side of a right triangle are already known, the remaining sides can be found using the ratios. Sine theta is equal to, okay, see, this is so ka twa, right? So ka twa. Sine theta is equal to opposite side over hypotenuse. Cos theta is equal to adjacent side over hypotenuse, and tangent theta is equal to opposite side over adjacent side. Okay, so this is basically the application of sine, cosine, and tangent, right? Shouldn't be too difficult. Let's do this together. So example says find the unknown side of x. Okay, so this is x. This side is x. X is the hypotenuse, right? Because so we can tell that x is the hypotenuse. Hypotenuse. Okay. And we know this is 30 degrees and this is 7. Okay. So which ratio should we use? Okay. So this is 30 degrees. So this is a reference angle, right? So this side, 7, it's the opposite side of the reference angle, right? And this side is the adjacent side. Okay, so what do we know here? We know that the opposite side of the angle is equal to 7, and we're looking for the hypotenuse. So we should use SOH, right? SOH. Okay, sine 30 degrees is equal to the opposite side over hypotenuse. Sine 30 degrees is equal to 0.5. So there are a lot of like very common angles. Okay, for example, 30 degrees, 60 degrees, 90 degrees, 45 degrees, 180 degrees, 270 degrees, 360 degrees, etc. So as you learn more about trigonometry, you might be asked to remember all the common trig values. For example, sine 30 degrees is equal to 1/2. Okay, but now you can use calculator. But in the future, it's possible that you'll be asked to remember all the like special values. Okay, so sine 30 degrees is equal to 0.5. So this is equal to, the opposite side is given. It is 7, right? And hypotenuse. So hypotenuse will be equal to 7 over 0.5. So that's 7 times 2, 14. Okay, it's very easy. So this question is basically an application, okay, application of the sine, cosine, and tangent, okay? Okay, so let's do this question together. So this question shows us, okay, this is a right triangle, 45 degrees is the reference angle, and we know the adjacent side, right? The adjacent side of the reference angle is equal to 8. And again, we're finding the hypotenuse. Okay, so let's write down what we know. So we know that the reference angle is 45 degrees. Okay, and we know the adjacent side of this angle is equal to 8. And we need to find the hypotenuse. Right? So here we need to use cosine. Why? Because cosine is equal to cosine theta is equal to A over H, right? Because ca. So A is the adjacent side and H is the hypotenuse, right? And here we know the adjacent side and we need to find the hypotenuse. So the only thing here is we need to know what cos 45 degree is. So cosine 45 degrees is equal to square root of 2 over 2. Okay, just this is a very off topic, but cos 45 degrees and sine 45 degrees are equal. They're both equal to square root of 2 over 2. Okay, so we know that cos 45 degrees is square root of 2 over 2, and this is equal to adjacent side is 8, and hypotenuse is the unknown, right? So with this, we know that x is equal to 8 over square root of 2 over 2, which is equal to 16 over square root of 2, right? Which is equal to 8 times square root of 2. Okay, so the answer is 8 times square root of 2. B, okay, part B. Okay, so let me say a little bit more about this. Okay, because again, I'm not your school teacher, right? I'm not your real school teacher. So I don't know how much you have learned about square root. Okay, so for example, like this kind of operation, I don't know if you know how to do it. Okay, so I assumed that you knew how to do it. If you have trouble understanding this, let me know, please. Okay.